Let's quickly review how to graph a quadratic function that has been transformed from its parent function. So first we're going to start off with what does the parent function look like? So we can remind ourselves that the parent function is quadratic, which is f of x or y is equal to x squared. We know that it looks like a U, either opening up or down. And we know that the table values for the parent function are 0, 0, 1, 1, 2, 4, because 2 squared is 4, and 3, 9. And if we plug in negative numbers, we know we'll get negative 2 squared is a positive 4. Negative 1 squared is a positive 1. So now that we have everything about our parent function, let's take a look at our function that we need to graph. We're going to start with the inside, the horizontal shift either left or right. And what we do with that is we say x plus 3 and we set it equal to 0. And we find that x is equal to negative 3. This is a vertical line that we're going to place at x is equal to negative 3. We also see that we have a vertical shift. It moves it either up or down. In our case, we have y is equal to a positive 1. So it moves it up 1 unit. Again, I am going to create a horizontal line, y is equal to 1, to represent that shift. And what we find is what I call our new origin. So now that we've done that, we're going to graph our parent functions, which with these values here, but we got to remember if we have a multiplier to multiply our y values before we graph them. And we can see from our equation that we have a multiplier of negative 1. This tells us that we know that our graph will not be opening upward, but opening downward. Because what we're going to do is we're going to multiply our y values times a negative 1. So that's going to cause this 4 to become a negative 4, this y value of 1 to become a negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. 4 times negative 1 is negative 4. And 9 times negative 1 is negative 9. So we're ready to graph. We're going to go to our origin and notice that we have the point 0, 0 as our point. So that means we stay at our new origin because we shifted the origin left and up. So now we're going to graph some points. Normally we would graph 1, 1, but because of our multiplier, we're going to go over 1 and down 1. For the next point, we have 2, negative 4. We're going to go over 2 and then down 4. 1, 2, 3, 4. And the last point that I have down here is 3, negative 9. So I'm going to go over 3, 1, 2, 3, and down negative 9. And we can see half of our parabola going like this. The other half is by going to the other points that we have up here at negative 1, negative 1. So we're going to go over 1 and then down 1. And one of the things I want to remind you is that our parent function is even. So this still that means that what we see on the left is what we'll see on the right. And we can see that our x is equal to negative 3 is our axis of symmetry. I'm going to go ahead and you'll hear me call it as AOS, but it is the axis of symmetry. What that means is that if I come to this point and I realize that it's 2 units away from that vertical line, I can go 2 units the other direction and find a point. In fact, that's our point negative 2, negative 4. So we can see that we would have the point over 2 and then down 1, 2, 3, 4. Likewise, we can see that down here it's 3 units to the right, so I'll go 3 units to the left, and there's my other point. So my parabola comes down this way. So a couple of things I want to mention. One is this point right here. It's known as the vertex. And we know the coordinates of our vertex. That is our new origin. And what we did is we went over 3 and up 1. So -3, because we went 3 to the left, and then +1. That we can find just from our shifts, from our horizontal shift and our vertical shift. We can find our vertex. The other thing I wanted to mention was the AOS. And the third thing I wanted to mention were these, well, there's 2 more, but the third one is this point here and here. These are our x-intercepts. These are the point -4, 0. The y value is equal to 0. And then we have -2, 0. Again, the y value is equal to 0. That's good to know because that tells us our x-intercepts. The other thing that's associated with the x-intercepts are the x values of our x-intercept are the same thing as what we call the zeros of our function. In other words, it's when our function f of x is equal to 0. That means the y values is equal to 0. So the zeros for our function are -4 and -2. So those are our zeros, are our functions. And the last thing I want to mention is this point down here. This point is what we call the y-intercept. It is at the point 0, -9. It's when the x value is equal to 0. And we find that it crosses the y-axis at -9. That concludes this short video.